What's new? Well, we've added 5 new columns, all related in some way or another to the first law of thermodynamics. So the first 2 of these columns ask questions to help guide your thinking about how these processes are similar and how they might differ. So let's work on column 7 here and look at the question, is the work in, out, or zero for this constant pressure expansion process? Well, there are several ways we can do this. Let's look at it first of all physically. So here we're looking at the system at an initial state, and it will have volume 1, and now we are going to allow this system to expand, and at state 2 we will have a larger volume, same system, same fixed mass. So here at state 2, the larger volume. So clearly we pushed back the surroundings to allow this process to occur. So clearly the work is out. The system did work on the surroundings. So we can also interpret this graphically. And the way to do this is to look at our pressure volume plot. So here we see that in going from state 1 to state 2 at constant pressure, from V1 to V2, that we did work, and the work being the area under this curve. And that area, since we moved from left to right, is also a positive quantity, so we see that the work must be out from that perspective as well. Last, let's look at the definition of moving boundary work. First of all, that where the defining expression is for work out as the integral of the pressure with respect to the volume from the initial state to the final state. And for our particular case, we have the pressure times the final volume minus the initial volume. V2 is larger than V1. So clearly this quantity here will be a positive quantity, and since our defining relationship is defining out as a positive quantity, we conclude once again that the work must be out for this process. Let's now compare the constant pressure and the constant temperature process and ask which produces the same amount of work starting at the same initial volume. You've already drawn the PV plots for these 2 cases. So let's replot these where we start them both on the same set of coordinates. So here we have pressure and volume. Here's our initial state, our initial volume, final volume over here, constant pressure, horizontal line over to the final state. And you derive that you have something that looks like, or something that is, a hyperbola. So that's constant pressure, this is constant temperature, so let's call that 2P, and we'll call that one 2T. And if we look at the work associated with these 2 processes, let's look at the work associated with the constant temperature process, the area under this curve. And we can see that that yellow area is less than the area under the constant pressure curve by this blue amount. So the difference in the 2 works is associated with the blue area. So clearly we see that the constant pressure process delivered the most work for this particular set of circumstances.